So that should give you a good idea of how to approach navigating around the different types of supercells. However, there are some factors that can complicate things. First, the supercell's orientation and direction of motion can cause things to be a bit different from what we talked about earlier. These are both modulated by the winds aloft. For example, in an environment like this, most of the winds aloft are out of the northwest. Much of that mid and upper level hodograph is in the bottom right quadrant. And that does a couple of things. Number one, it allows the storm motion to be much more toward the southeast, and it can change the orientation of the supercell. The hook echo might be on the west or northwest side of the storm, compared to our example earlier in which it was on the southwest flank of the storm. And the precipitation will be vented off to the east or southeast of the hook echo. This is a classic supercell, and before we talked about how being out to the east of a classic supercell is best. It gives you the best look into the mesocyclone region of the storm. Well, now with a storm motion to the southeast and the precipitation vented as such, being out to the southeast of the updraft and mesocyclone would be your best bet. Being off to the east of the mesocyclone would put you right in the bear's cage, and maneuvers like hook slicing, which before was from west to east through the hook, now would be from northwest to southeast through the hook. So always be aware of the winds aloft and what that does to your supercell orientation and direction of motion, and adapt as such from the examples we talked about earlier. The forward speed of the storm can be another complicating factor. Faster moving storms, 40, 50, 60 plus miles an hour, give you a much lower margin for error. So in those cases, you may want to pick a spot downstream and wait for the storm to come to you. Versus with a slower moving storm, it's much easier to make adjustments around the storm as far as your positioning goes, and you can get closer to the storm without risking falling behind.
Join our channel membership and unlock extra videos, live group coaching, and unlimited Q&A.
Auxiliary cells around your supercell can also complicate things. Supercells need a perfect balance of inflow and outflow to become tornadic. If the storm is experiencing strong storm relative inflow, there needs to be a lot of outflow to balance that out. Where does this outflow come from? Auxiliary storms on the rear flank of the supercell. We can diagnose the degree of storm relative inflow from the hodograph, whether that's in forecast hodographs leading up to the event or in observed soundings in proximity to your supercell during the event. We talked about storm relative inflow in our last episode of this module when we discussed mini supercells. As a refresher, the storm relative inflow vector is drawn from the storm motion to the low levels of the hodograph. For this technique, we'll use the surface point on the hodograph. In this example, we have over 50 knots of storm relative inflow. That is a ton of storm relative inflow. That means that supercells in this environment are going to need a lot of auxiliary cells to provide outflow to balance out the strong storm relative inflow. On the other hand, supercells in environments with weak storm relative inflow like this one, here it's about 25 knots, don't need as many auxiliary cells to achieve that inflow-outflow balance. So what does this have to do with navigation? Well, it can make navigating around the rear flank of a storm somewhat difficult. Whether you're diverting around a storm, driving south, then east in front of a storm, or you're performing a hook slice maneuver. These auxiliary cells can make driving conditions very difficult. It can clutter the hook with more precipitation than normal, allowing visibility to decrease drastically, and therefore turning the hook slice maneuver into a very dangerous one. And overall, it can perhaps turn a classic supercell into a little bit more of a grungier one. Maybe not fully high precipitation, but it can introduce some extra precipitation into the rear flank of the storm, making things a little bit grungier from a visibility perspective. So always be aware of auxiliary cells on the rear flank of a supercell and adjust your strategy accordingly. Always be aware of secondary circulations, especially if you're navigating close to a mesocyclone or tornado. Always keep your head on a swivel and watch out for satellite tornadoes. And on occasion, spin-up tornadoes can occur on the rear flank downdraft gust front. This boundary will emanate from the mesocyclone of the storm down to the south or southwest in a typical eastward moving supercell. Oftentimes, these circulations will be anticyclonic in nature and often somewhat brief, but extreme caution should be taken, especially if you're just south or southeast of the mesocyclone of a storm.
And remember to check out those links in the description below, and then watch another video.